Hello, my name is Rodrigo Santos, and today I'll be walking through the network prototype I worked on my final project of the class CT240 at Capital Technology University. The goal of the project is to design a secure, efficient, and scalable network that connects three campuses, ensuring reliable access to both internal resources and external services. Slide 2. Now, the project focuses on creating a secure network spanning three campuses: Laurel, Patuxent River Naval Station, and Montgomery County Airpark. These campuses need to be connected while ensuring the data that can be securely transmitted between them. The network must support hundreds of users across staff, faculty, and students. All core services such as webbing, hosting, databases, course platforms, file and mail servers will be centralized at the main campus in Laurel. Communication between campuses will be encrypted via VPN. Additionally, VLANs will be used to segment users into separate logical groups, improving performance and security. For the network topology, this slide shows the network topology, although I had a hard time creating everything, but this image can be a good example of everything. So with the Laurel campus acting as the central hub connecting to the other two campuses via pinpoint links. Each campus is equipped with Ethernet switches for local traffics and VPNs to secure intercampus communications. To ensure redundancy and load balancing, we're also incorporating a loop topology using multiple paths between switches and routers, along with failover in case of link failure. VLANs are used to segment the network for staff, faculty, and students. VLAN 10 is designed for staff, VLAN 22 for faculty, VLAN 3 for students. This segmentation not only reduces network congestion but also increases security by isolating each group's traffic. With its design, staff, faculty, and students won't be sharing broadcast domains, which will keep network traffic organized and improve performance. In my opinion, VLAN and trunk configurations are the ones I like to do the most. On slide number 5, VLAN configurations example. For Laurel campus, we've defined IP addressing for each VLAN. VLAN 10 for staff, we use 192.168.0.1/20 subnet. VLAN 2 for faculty uses 192.168.16.1/23, and VLAN 30 or 3 for students use 192.168.18.1/25. On the switch, fast Ethernet ports are allocated for each user group. Trunking should also be set up between the switches and routers to allow for inter-VLAN routing communication. On slide number 6, inter-VLAN routing. This is also something I enjoyed a lot. To enable communication between different VLANs, we must use a method known as router on a stick. Each VLAN assigned as a subnet interface on the router. For example, interface G0/0.1 for VLAN 1 and G0/0.2 for VLAN 2. .1 queue encapsulation is used to tag the traffic with appropriate VLAN IDs as it moves between the switch and router. This approach enables the router traffic between VLANs, making inter-VLAN communication possible. Routing protocol, EIGRP. This is one of the hard ones. To efficiently handle routing between the campuses, I've chose EIGRP as the routing protocol. This is known for its scalability and fast convergence, which makes it ideal for a setup like this. By enabling EIGRP on all routers, the network can quickly adapt to changes in the topology and route traffic efficiency. In this configuration, I've used a wildcard mask to define the network subnets include in the route table. VPN. This is another hard one for me. um, since the campuses need to communicate security, a VPN is essential to ensure the security. The VPN ensures that data sensitivity, um, such as admissions, records, internal emails, are all encrypted. The VPN is established in two phases. Phase one, using ISAKMP, establishes the secure communication between routers, and phase two uses IPsec to encrypt the data. After defining the ISAKMP policy, we go ahead and configure IPsec and apply the crypto map to the interfaces. Very complicated. Now, for redundancy with Ether channel ESTP. To provide network redundancy, each channel, Ether channel, is implemented to agree multiple physical links into one logical link. This not only increases available bandwidth, but ensures that if one link fails, the other can still carry traffic. To prevent loops, we use the spanning tree protocol, STP, which ensures that only one active path exists at a time, while the backup links are enabled in case of system failure or anything fails. This combination ensures that the high availability and load balancing across the network. With the use of VLSM, we can efficiently allocate IP addresses according to the needs of each LAN, each VLAN. For example, the student's VLAN uses a /25 subnet, while the staff VLAN uses a /20 subnet, ensuring that ensuring what we have enough that we have enough IP addresses for each group. And DHCP simplifies IP addresses management by assigning automatically addresses to devices. And this configuration of the HCP pool for staff, for instance, assigns IPs from the 192.168.0.0/20 range. So slide 11, testing and verification. Finally, testing and verification are crucial to ensure that everything is functioning as expected. We will test communication with VLANs and between campuses using tools like ping and traceroute. Also, commands such as IP route, show IP route, and show crypto ISAKMP SA will be used to verify and routing table VPN tunnels status. Through testing, we'll ensure that the network is secure, efficient, and is scalable. That's it. That's the end of my presentation. Thank you very much.